So our lesson objective is I can correctly classify various numbers in the real number system. So we have a question here. What is the real number system? So I think the best thing to do is first create the real number system. So first of all, the real numbers include pretty much all numbers that you can possibly think of. The numbers that you may have learned about initially are considered whole numbers. So like 0, 1, 2, 3, 4, and so on. These are considered whole numbers. So as you can see, these are our whole numbers. So that's 1, 2, 3, and 4. Another number is also, so now we have 0 included. And another type of whole number, which is also a different kind of number, is considered an integer. So this number it includes all whole numbers, but it also includes all negative numbers. So it includes everything going from negative infinity to positive infinity, as well as, and naturally that just also contains all the whole numbers. And in addition to our integers, we also have our... So now we have one more definition. Well, we have two more, but the first one we're going to do is rational numbers. So rational numbers also include integers and whole numbers. The correct definition of these is that they're considered fractions, terminating decimals, or non-terminating but repeating decimals. So some examples of rational numbers. I'm going to actually kind of put them down here. They're in pink, so we know they're the same. So we might have our integers. We might write them over 1. That makes them a fraction. We might have other fractions that cannot be written as integers. We might have terminating decimals. So this is a terminating decimal here. It ends. We might have a non-terminating but repeating decimal. So something like, oh wait, let me not change the color. 0.33, and it might have dots, but typically it says like 0.3 repeated. That's technically also a rational number. That's pretty much the one I think a lot of folks make a mistake with. The other mistake is they tend to not recognize that whole numbers and integers are also considered rational numbers. But so these all are going to go into their own little box. So we have what I drew here was literally a box or a rectangle that is the same size, because I want to emphasize that these numbers, even though there's not subcategories like there are with rational numbers, like that includes integers, whole numbers, the irrational numbers still has the same amount of numbers. There's infinitely many rational numbers, infinitely many irrational numbers. So without further ado, what makes a number an irrational number? It is a non-repeating and non-terminating decimal. There's going to be two types of irrational numbers that we're really going to see here. That includes the number pi, and that includes the square root of non-perfect squares. And we're going to use our calculators to double check that if something's a non-perfect square or not. So this is another way of representing our chart from the previous page. I'm going to go ahead and write examples for each of the numbers since we kind of did that already, and then I'll show you the notations. So for real numbers, the symbol's an R. For irrational numbers, it's an I. For rational numbers, it's a Q. And I'm sorry, for real numbers, it's not an R, it's like a special R. You draw two lines like this, and then you start on this one, and you draw an R onto the next one. For integers, it's a Z, but it has like this extra line in it. So that's the integer symbol. For whole numbers, it's W, and for natural numbers, you draw the two lines, and then you create an N from here. So that's how it looks. So now we're going to name all sets of numbers to which each number belongs. So again, I have my little world here. I'm going to draw the symbols in for each of them. So 30. So 30 is considered a whole number, Because it's a whole number, it's also an integer, and then it's also a rational number, and then it's also a real number. Negative 11, that's not a whole number, but it is an integer, it is a rational number, and it is a real number. 5 4/7, that's a fraction, so that's a rational number and a real number. Square root of 21, we're going to put that in the calculator, and that is not a perfect square, so this is irrational, but it's still a real number. 0 is a whole number, it's an integer, it's a rational number, it's a real number. Negative square root of 9 is really the same thing as negative 3. So that is actually an integer, a rational number, and a real number. 6/3 is the same as 2. So it's an integer, a rational number, and a real number. And it's also a whole number. Sorry about that. Pi, that's going to be an irrational number, but it's also a real number. 5 and 3 repeating, that's going to be a rational number because it includes a repeating decimal and a real number. Square root of 144 over negative 3 is the same as 12 over negative 3, which is negative 4. So this is an integer, a rational, and a real. Negative 2.875 is a decimal, so it is an integer, but it's a rational and a real. And then the square root of 17 over the square root of 17, it looks like it's going to be irrational, but it ends up being 1. So it's a whole number, an integer, a rational, and a real. We're going to do the same thing on this page. So we have the number 7. So that's going to land, I'm going to just ignore the whole numbers because we didn't use them and I don't feel like including them now. 7's going to be a whole number, so that includes all integers. I like this diagram better. B, this is 36 over 12, so that's really negative 3. So that's going to be and I'm going to put the letter. That's going to be an integer. Negative square root of 36 is negative 6. So again, that's going to be an integer. Pi is a irrational number always. 6.48 is a terminating decimal, so it's a rational number. Negative 2 is an integer. Negative square root of 10, we can put that in the calculator. We see that it does not come out nicely, so that's going to be an irrational number. H is a whole number because it includes 0. 2 1/6, that's a rational number. Negative 0.7 repeating, that's going to be a rational number as well. And then square root of 4 over 81 is the same as square root of 4 over the square root of 81, which is 2 over 9. So that's going to be a rational number. So after this lesson, you should be comfortable with classifying various real numbers.